Thank you very much. Again, thanks to all our panelists. We wanted to give people an opportunity to ask the panelists any questions that they have based upon their presentations. So we'll spend 10 or 15 minutes doing that and then get into the robotics demonstration. So any questions out there in the audience? Crickets. Oh, we got one over here. Oh, and I forgot the spotlight. We'll do that after the Q&A.
We're actually kind of a mixed model. So at the heart of it, we're a core research facility at the university. So that the core research facility sets a price that we can charge the federal government or companies to use the facility, whether it's on a non-exclusive hourly rate or you rent out the whole center for the day or a week and longer. We use sponsored research as well. So we have a couple of contracts with NIST, obviously with DARPA. So we do some contract work for the government as well as for companies. All the pictures I showed you on the presentation were people who agreed to let us show their robots. Obviously, if they didn't agree, we don't show it. Whoever pays for the testing owns the data. And that's the way that we function at the nerve centers. So if your sponsor pays for the testing, then they own the data on your robot. Whereas if you pay for it, then you own the data on your robot.
Great question. Who wants to tackle that one?
Yeah, I'll take it. It's difficult. It's very hard. So my company deals with robots that are much easier to do, and it's still $500,000, $2 million to the cost. Engineers and the universities are working on that now. You see robots that kind of replicate some of the things, but to do it perfectly is hard. Someday, yeah, maybe you.
Yeah. Anybody else? Yeah.
Yeah, actually, if you saw some of the robots from the DARPA Robotics Challenge finals, so you saw those. Yeah. There were a lot of robots that were trying to turn valves and open doors and drive cars and do things to help after a nuclear disaster. And the most watched video is all those robots falling over. So it's hard just to even keep the robot standing up, let alone to do the really hard tasks. And there's a lot of things that we can do as people. If you think about having to turn a faucet or a handle or a valve, you can feel what that feels like. When that robot's doing it, it doesn't have that force feedback, so it doesn't really know what it's doing. So there's a lot of problems that need to be solved before we'll be able to have really good humanoid robots.
We had a couple references in your presentations about robotics and automation and those being the cause of eliminating jobs. Could one or two of you give me some examples where robots are not necessarily being used for faster, cheaper, lower cost, but for other areas that are beneficial to the industries? Kevin?
So a lot of
you pulled it right up in there.
So a lot of the stuff that we end up doing in terms of the automation technology, makerspace stuff. So it would be a 3D printer, CNC router, laser cutter. Those are our sort of bootstrap staple machines that we always start with. And we always try to encourage people to think about the types of products that these machines could make that you couldn't make otherwise. A great example of that is printing robot legs with flexible materials with all of the cable guides built right in. I know Boston Dynamics is working on 3D printed structures for the robots that have all of the hydraulics and valving printed in. There are a whole just unimaginable range of things that can be expressed with a computer and manufactured by a printer that could not be manufactured with a milling machine or injection molding or any of the traditional high volume technologies. So there's a whole range of new things that could never have happened before now that are going to start popping up. And I think those are possibly the most interesting things to take a look at.
Great.
Wasn't really talked about here, and most of us are a little bit more in the manufacturing space, but I think a lot of the big advances in medical technology, like even surgery, has been automated and clearly has been shown to be, better than a person could do it, more accurate, cleaner. There's machines now that can do hair replacement. Maybe a candidate for that, and it's better. It's faster. It's better than, and we're not talking about cost here,
Right.
than if a person was doing it. So there's lots of examples of those out in the world, especially in the medical space.
Yeah. Holly?
I think it's also a question of we're just going to create new categories of jobs. Just like the computer didn't drive people out of jobs completely, it just changed the jobs. And, I always say robots are still going to break. So we're going to still need a bunch of people to actually maintain those robots, to build the new robots, to program the new robots. So we're just changing the way jobs are going to look.
All right. Bill?
Yeah, Nubotic is starting to work with a jewelry manufacturer, and jewelry is sold in December for Christmas. And because of the cost of the raw materials, they can't keep much in stock. So they make a ring, and then it's in a store less than 3 days later and sold 2 to 3 days later after that, because the platinum's expensive, the diamonds are expensive. And what this means is for their assemblers that they have to show up for work at 5 in the morning in November and December, and they stay until 10 p.m. at night. And these are people that have families, they have kids, they have other lives, but it's a really well-paying job, and they want to keep the job because it's easier in the spring and summer, but they have to, work like dogs now. And so the robot is taking over the excess capacity in those winter months, so these people can have better lives and have a life around the holidays. And then, so it's not necessarily faster and cheaper, it's just elastic workforce.
A great example of rethinking the way people interact with their manufacturing and what are these controls. A little bit control theory, and yes, we have some advanced control theory stuff going on in our software, but what is new and novel is the application of those control theory techniques, we call DH parameters, scaling of designs, can in the new software be used to generate the physical structures that implement them. So what we've done, for example, our sort of little novel value add is flipping the modeling and development system and inverting it, where you start with the mathematical model of what you would like it to do, and the software does all the engineering work to make the physical structure that implements it. The hexapod is the example of that. I'll show the software. I don't know what the demo thing is later, but yeah, I'll be available to show that off later. There's even more interesting things happening in computational geometry. I know Steve's been itching back there. It probably has some question along those lines. But yeah, this idea of expressing customer intent and having a user interface to allow them to express that content in a way that propagates through the production line all the way back to the raw material sourcing is something that we can start looking at. MMO video games is a good example. Massively multiplayer online video games is a great example of what a really good user interface looks like to a completely useless backend. Well, imagine that sort of interface, but for a real production backend. Kerbal Space Program is maybe a better example of a user interface that has allowed kids to do orbital mechanics. Like they learn the mathematics of orbital, the terminology, the lingo, the jargon, really, of orbital mechanics to the level that NASA engineers sit around talking about it, just sitting in their living room debating the best way to play their video game. And to hear them actually say that will blow your mind. Like, well, you're 5 degrees off the limb. You're not going. And it's like a 14-year-old kid who really, only has so much of understanding. This becomes their terminology. So that application of mathematics with user interfaces and applying that to useful backends, that is going to be the next big push as gamification really hits the engineering, development, and production closed loop. Or at least that's my
Great.
I mean, the other point I'll make to that is, and it's not quite as sexy as artificial intelligence, but just the just raw computational power of, the thing in your pocket, your phone and everything else, but just even with computers allows us to do things that we would always have done before, but you can do it automatically. So things like, you saw robots moving around a warehouse, and so we're keeping track about exactly how fast that's moving around the warehouse and what paths it's taking, and then all that data can get crunched back, and now it can self-optimize. And that's not quite artificial intelligence. It's what you would have done with a stopwatch before to be able to time things and write it down and say, okay, make it go this way next time. You can do that. It can happen automatically now. So, yeah.
Great. Did you?
We're also taking huge advantage of consumer electronics. So your nice little tiny camera in here, it's so different than 20 years ago when you had to have huge CCD cameras, build your own frame grabbers. You can put a Connect on a robot now and have a much cheaper sensor. So there's a lot of things that we're taking advantage of on that side as well.
We're actually speaking, not myself, but a colleague. We're invited to a conference tomorrow, which is on trucks, automated trucks. So it's being held in Detroit tomorrow and Thursday. And we were invited. We're the small robot company, but a lot of the technologies that we use to be autonomous, which is using vision and sensors and everything else, are similar. I think our risk factor is it'll hit you in the ankle, and that's maybe that's it. But yeah, it's a huge issue, and I think, but at the same time, it's one of those things that I think people look at least personally, I look ahead 5 or 10 or 20 years, and maybe it's not for just people. You could debate whether that'll be for people driving their own cars, but you could see the benefit in terms of fleets of trucks, and because that's also not an easy job, and people get tired, and in some ways that's unsafe. So I think there are certainly advances that will, and it's coming faster than everybody thought, right? I mean, 2 or 3 years ago, I think people said, autonomous cars, and now you hear it everywhere. I think that's coming. Yeah, Tesla's. Yeah, I mean, they even had to back off in the last couple days about what they're allowing people to do with their car. So I think that's certainly possible. And if you look at it as a way to improve either the workers' lives who drive, or personally us driving, you could see that will happen. I think that will happen. I think one of the challenges. It's interesting. One of the challenges with the Google cars driving around, I think, and this gets into artificial intelligence and the difference between computers and people, is they say almost all the accidents of the Google cars driving around is when the car did exactly what it was supposed to do. And the person who's, we don't do exactly what we're supposed to do when we're driving around. Do we all stop exactly at the stop and, stop for 2 seconds and count to 2? We don't do those things. And we take visual cues from other cars, and a lot of those are subtle. And I think that's the challenge, is trying to, what people do in those subtle cues when they're driving around and not exactly following the rules, and having the robot cars do it and try to mimic that.
Yeah, who do you make eye contact with when you're crossing the street on an automated car, right? One problem is that even if you have failure in 0.001%, what do you do with that? You've really got a human who's out of the loop at that point, and you've got somebody who you've told it's an automated car, and maybe they went and had a couple beers after work because they were in an automated car. I mean, I think Google is looking at this in some sense the right way, because they've taken out that steering wheel, except the one that they have to have because it's required in California, so that the liability issues aren't on you anymore, because you can't possibly take over control or be expected to take over control of that vehicle. But the out-of-the-loop problem is a big one, and there's a lot of investment. I mean, Toyota's putting in $1.2 billion over the next 5 years into AI and automated cars.
I mean, it brings up a challenge about safety standards. Not just cars, but robots in general. And one of the challenges in the robotics industry is being held to safety standards that are fair, but when you compare it to like the other stuff, so a perfect example is on the farm. So we're on the farm with our robots, and we're being held to certain safety standards. And I look over and I see other stuff on the farm, which is scary. And maybe rightly so, robot, because they are autonomous and there isn't a person there. But there's lots of examples out in the work. A chainsaw, like how safe is a chainsaw, right? but, or people standing on a subway platform with a subway, subway car coming by. How safe is that, right? But robots are being held, at least today, to a standard that's way up here in terms of safety standards. And that's a challenge, because if it's way up here, it doesn't get commercialized because you can't get it out the door. So I think that's, for people in robotics industry trying to commercialize products, I mean, certainly we want to make something safe, but it's a challenge when the bar is way up here and then you look over and you see somebody, farm equipment that the guy welded together himself. I'll tell you a real quick story. The way they trim things in a nursery with a trimmer is they make their own trimmers. And they build a base. They weld a big base, and they take like 10 lawnmowers, and they take the wheels off the lawnmowers, and they just put them on top of the base, and they fire them all up, and they push it down the field. Yeah, and so that's what they're doing, and then I've got to have a CE mark on my robot. Yeah, I mean, I think it'll depend a lot about, will it matter for the machine that's putting in my hair? Yeah, I'm not sure. Would it matter for the robots in the warehouse? I'm not sure. But certainly for cars, it's going to matter for if it makes more automation moves its way into defense. Certainly that is much more of a concern. So I think it'll depend a lot on the application and what it's being used for.
I actually am part of a conference committee there's a conference called We Robot, which looks at law and the robotics together. And there was a presentation last year where people were talking about creating a digital signature for surgeons so that you couldn't have a man-in-the-middle attack. And actually looking at how the surgeons operated the actual joysticks and categorizing that. So somebody else tried to man-in-the-middle it, and they operated a little bit differently, that they would actually stop the surgery, which I thought was a really interesting concept.
Great. Well, I wish, Kevin, did you have something?
Well, security is a big issue. It definitely is something that we should be considering, especially as we move into the Internet of Things, and even worse, the cloud of the Internet of Things. Just buzzword on buzzword there. Yeah, with processing big data, which contains medical records, of course, because, why wouldn't it? We do have this big problem, and we don't have a solution. And what's probably scarier is that the solutions we have are disappearing faster than new solutions are showing up. More crypto is being broken than being created. We just got this announcement that the NSA really has broken pretty much all of the internet crypto, and it's not secure. So maybe the other side of this is, Foucault's panopticon. You say everyone's watching, make stuff that's validated through the watching. Make the fact that it is being observed part of the process. Blockchain technology is a better way of solving this problem through group consensus, as opposed to essentially a really complex security through obfuscation. If you think of most of the way we do security now, these passwords, these cryptographic keys, it's very fancy obfuscation, which can be defeated by a near infinite amount of resources. Well, there are plenty of organizations that have near infinite resources. The NSA is one, and probably any other nation state you'd like to reference will obviously be inside these things. So how do you operate them? Perhaps the digital signature system, although that's another obfuscation problem, because you're validating against a hash. Perhaps a better way is through group consensus. Made safe is a different strategy on cryptography, which deals with the time signatures of moving data in and out, and validating data hasn't been messed with literally at live in and out of your application. Blockchain is Bitcoin is an application of blockchain, but this idea of having a public ledger of information that can be referenced against, solving DNS issues, for example. There are strategies, but the strategies are narrowing, and the broken strategies that we came up with in the past are accumulating. So yeah, this may very well be an issue.
Great. Well, please join me in thanking our panel for their presentations and their Great Q&A.